This is about creating documentation. Documentation as a Windows help file, but also as a PDF, RTF, electronic book, whatever you like. But we are focusing on compiled HTML, CHM files. So the goal is to create a fully fledged compiled HTML file, but I would like to show that it is possible to extract a lot of useful information automatically from classes and methods and fields and properties. Cheers. In order to achieve that, I'm going to make use of a third-party tool which is called HelpAndManual, which is a fully fledged editor in order to create such documentation. But we are using this as a compiler from APL. Nevertheless, it's, I think, a good idea to have a very short look on what that software is able to achieve and why I've chosen to use this one and not one of its competitors. So I'm starting HelpAndManual. I'm going to spend on this probably 3 minutes, not more than that. I installed a new graphics driver yesterday, thanks to Jonathan, who told me why my notebook was not able to put a picture on the wall and at the same time make good use of its display. Since then, my machine seems to be considerably slower. So in order to create a new project, I decide to create a new project from scratch rather than decompiling an existing HTML file or help file or whatever. That is possible as well, but we are not interested in this. Sorry? Well, you have to remind me probably several times, I'm afraid. When powerful voices were allocated, I failed to turn my hand up. And as a default, it's suggesting to create a couple of topics already. So that's the reason why I do not have to spend much time on this. It comes up with an introduction, a container with two subtopics and some text inside here. And it's probably the by far best software you can choose to create a documentation by editing files, simply because it is offering all sorts of helps. For example, to create a link, you simply do something like that and the job is done. Similarly, if you would like to create keywords, that's it. Now, in order to create an HTML file, I need to compile that in HTML, in HelpAndManual speak, to publish it. And here you can see that the software is offering much more than only help files. You can create a help file, but all sorts of other stuff as well. And you can also decide whether a topic should go in any of those or only in particular ones. So it's quite a powerful thing to do. There is our help file. The two topics, the second one contains a link on the first one, and in the index, which needs to be prepared for. First, we see our several keywords we have introduced into the two topics. So far, so good. Why is this of any interest to APLers? Well, there is a tab called XML source. And that's the native file format used by this software. Actually, you could edit this tab, although this is not suggested because you have to know exactly what you're doing. And why should you? Because HelpAndManual is automatically updating the XML as soon as you do something in the Edit tab. But it gives you an idea how the XML looks like. Now, when that is a native file format, there is nothing wrong with creating such an XML file from APL. And then at the end of the whole process, tell HelpAndManual to compile all these XML files and to create a help file for us. So let's look at a very easy example. I don't ask these questions anymore. There was a time when people were quite doubtful about XML and why it was created in the first place. But I think it's widely accepted now that it was a very good idea to have this as an ability to deliver data, to exchange data, and also even using it as a native file format. Imagine a workspace which is saved on the disk as an XML file. We could create workspaces automatically. That would be nice, right? So I'm not asking these questions anymore. And the same regarding object orientation. I think it's widely accepted that that is a useful thing to have. So it's something which makes HelpAndManual, something that makes writing documentation almost enjoyable. We all tend, I dare to say, we tend to think of documentation something we have to do, but we don't like it. At least that's my impression. So let's go through APL. This function executes 3 steps. It creates the XML files in the first place, then it compiles the help file with HelpAndManual, and finally it shows the resulting help file. And I'm tracing through the function which are doing exactly that in order to explain what is going on. That simply creates a reference. So in order to call stuff inside the ordinary namespace HelpAndManual, I don't have to type the long thing anymore. I can use HMA as a shortcut. Same is true for this one, because inside the ordinary namespace HelpAndManual there is a second ordinary namespace called enums. It contains a couple of classes which allow me to use the enumerations. So I use this as a reference as well. I made sure that leftovers from my last attempt are getting deleted by cleanup. We are not interested in this. And then I need to set a reference inside the class XML.project, because XML.project makes use of a couple of utilities, and it has to know where these utilities resides. It tries to find them in root. So if they are available in root, it works fine, but if they are located anywhere else, it can't find them naturally. So it's a good idea to have something like ref2utils and assign it a reference so it can find all the stuff. Now, you might think I'm going to do this once and forget for the rest of my life about this, but unfortunately this is not true. As soon as you edit the class, say in a tracer, and you refix it, that shared field is not any longer available. So the reference is lost.
Fortunately.
Well, it depends on your view. In terms of continuing with the tracing through the class methods, it's unfortunate. It is fortunate because, for example, if you copy something like that and the reference has already a value, all sort of strange things may happen and will happen certainly. That's the reason why it's done dynamically. And then finally we start to create the project. That creates a new instance of the XML.project class, and it takes 4 arguments. I can't remember actually what it is. It doesn't matter, it's probably name and path name. So the path name is relative to the current working directory, and it also gets a reference to the utils namespace. And after having created that instance, I'm going to set a couple of properties which we need in order to create the result we are trying to achieve, the compiled HTML file. The author, copyright, title, summary, comment, and very important, the output folder for the files we are going to create. Although we are not interested in PDFs and RTFs and ebooks and all that kind of stuff, but we are interested in the compiled HTML stuff. So that is set to a real thing. Sorry? No, I'm not.
Dilek.
Oh, lucky you.
Now this notebook was connected to the power line the whole night. And the only thing I can imagine is that nevertheless I run out of power. I don't understand how and why.
There's one more else.
Yeah. Or there was a dialogue in the background telling us updates are available now. Would you like to restart your computer? You can delay this, or and if you don't do anything, it is rebooting, right?
Best regards, I'm Bill.
Yes. Very nice.
Okay, people will remember your presentation.
Not sure how I shall take that up. Going to ignore that right now. Come.
Did you ever see the Adrian Smith's help generator?
Yes.
To generate help for writing down version 7 back then.
But this was Windows help.
Yes. But
Not
it also
talking about
produced
And also it was
HTML.
quite limited in its abilities. You can achieve much more nowadays. Yeah, we discussed the properties when we got slightly surprised by Bill Gates. So that creates a project. Now we have an instance which has the name Delta My Project 1, and everything we are doing right now is somehow related with that instance. We will see how that works. But before we can actually create a topic in the help file we are achieving, we need to create a couple of things, in particular styles, for example. Now, that is easy to understand, I think. What we do is we create an instance of a class which is called style, and we give it a name, in this case header 1, and we assign the result of quote new, the reference, to a reasonable name. That comes with a quite large of default properties: margin, padding, font size, font style, all sorts of stuff. So the defaults are supposed to work just fine, and the only thing we need to do is to set the properties we want to change. So for the header, we set it to a reasonable large font, and we set the bold property, and that's it. The next style is normal. We of course need also a style APL, which is no surprise using the Unicode font. We make sure that it is not wrapping, because we don't want to have wrapping in APL code. And we want to keep stuff together. So we set page break inside to avoid, which has only an impact when you print, of course, the file, not when you display it on the page. There are also styles for lists, headers of level 2 and 3, and 2 styles for tables. We will see in a second why there are 2 styles. Now, hidden header might sound a little bit crazy. Why should I create a header which is hidden? But what it stands for is you get a piece of text with a link, and if you click at the link, the text underneath expands and shows up. So you can hide information which is probably a little bit too complex to start with. Now, all these styles are created, but we haven't connected them with the instance we created earlier on so far. That is going to happen in another function. But before we do this, we also create, no, sorry, that's not true. I'm going to do this right now in Add Styles. This simply takes all the instances we have created so far, which are all classes plus our My Project 1 instance. So we need to extract that with without, and we assign these styles to the instance. So Add Style is, so to speak, the connection with the styles we've just created. Now we can make good use of them. We also need inline styles. What we've created so far are styles which we can assign to paragraphs. So the whole paragraph will be a header or APL or normal or whatsoever. But we need also inside styles in order to, for example, mark up a piece of code inside an ordinary normal paragraph. And as you can imagine, this is true also for bold, italic, and this kind of stuff. Now, these are not assigned to the instance, the project instance, because these instances return XML code, which is then inserted into an ordinary paragraph. We also create windows. We are not looking into this, but there are help files which offer more than one window. We are not interested in this. We only deal with one main window. And then we start to do the real thing, to create topics. Every single function we are looking in right now is creating such a topic, and it takes 2 main things. It takes the text, which is going to be the topic, and it takes a level. If it is level 0, it's a top page, and if it is a level 1, it will be a child of the last main topic. So this takes an instance and a name, a title, and creates a new topic. And that new topic is assigned a name, hierarchy, parent. And the only thing we need to do is set the level and some text. And you can see how styles are used. The method as paragraph is taking a piece of text, is wrapping it, and it's assigned to the property header. Similarly, we use ordinarily the normal style, the method as paragraph. It takes the text, wraps it into XML, and it is added to our topic by calling the method add paragraph. And then we save that thing, which exists so far only in the workspace, by calling the save method in the folder we've created earlier on. And finally, because our project so far has no idea that we've created a topic, finally we call the method add topic, give it a reference as a right argument, which points to our just created topic and add it to our project. These are the basic steps to create a topic from APL. And that is done over and over again, so we have no reason to look into the other sub-functions, with the exception that there are specialties. For example, this one, because it assigns APL code to our help file. So let's look into this one. Again, it creates a topic simply by creating an instance from the topic class that assigns the level and also a header, and then things are getting interesting. Here we use the name of an ordinary function and create something we can use as input for our text file, help file. That is how it looks like. And we assign this to the topic by calling the as paragraph method of the style APL instance. And that's it. Now the compiler will know that that piece of text is supposed to turn up in our help file as APL code, and we'll use APL385 Unicode as a font for that. There are two different ways to assign styles to APL code. One is assigning it to a single line, and another one is using a whole block. A whole block can be displayed a little bit differently from a single line. For example, if you can add a little bit more space on top and bottom, but the lines themselves should be close enough together to recognize them as an ordinary APL function. And then again, we save it and assign it to our project. There are other examples, for example, how to create an ordered list, but there is actually nothing new because it's the same principle. You choose a proper style, you assign the text and assign it to the project, and that's it. So there's no point in going through all this stuff. The final step, when we've created all the topics we are interested in, is to create a table of contents. And that simply tells the function create the table of contents to go through all the XML files and compile the stuff together, which is done by the method add topics automatically. It's looking inside, is collecting all the references we have assigned and knows what to do, and we write the table of contents to the file, and that's it. And then we save the whole thing on disk, and we are done. That is the folder where I've written all the topics into. So by putting one of these files into an editor, we can see what the outcome of that is. That is how it looks like. Final step. We need to compile the XML files. This is again done more or less automatically. The only thing that needs to be prepared is a path which is pointing to the HelpAndManual .exe file. It tries to find out automatically from the Windows registry whether this is going to work with the next version. You never know. I've done this several times for browsers, and my experience is whenever browsers are coming along in a new version, you can be almost certain that the Windows registry key are renamed, located elsewhere, or anything else has changed, so it doesn't work with the latest version. It's really annoying. And because we are using the command line interface, we see a DOS box, and because it's a small help file, it's fast, with very complex help files that can take a considerable amount of time. And finally, we display the help file. Here we are. Here you can see the two different ways to display APL code. This one is slightly differently formatted. This is inline APL code. This is inline bold, while the whole paragraph is an ordinary, normal paragraph. Short look at lists, ordered or unordered. So there are all sorts of, actually I think in this example there are all opportunities realized which we can achieve with HelpAndManual as it is. Okay, but this is only the start. We haven't generated any documentation automatically from classes. And that was, as I mentioned, my primary goal. So how is that going to be achieved? Well, what can we achieve by looking into a class? A class declares its constructors and their syntax. It also declares their fields, and if the fields get a value, it's also the information is also available, which is the default. We can look at the properties, shared and instance ones, and of course the methods. And the methods, again, as well as the fields and the properties, might have shared instances or both. So all these pieces of information are available in the class script, and we can extract them automatically. I forgot the destructor, if there is any. The output formats I have already mentioned, so there is no need to look into this. A couple of years ago, I introduced a project which is called ADOC, which is doing exactly that. ADOC is a self-contained class, is available on the APL wiki, and if it is given a reference to a script, it extracts all the information inside that script automatically, prepares an HTML page, and displays it. So it is pretty much doing what we are looking for, but it is not creating an compiled HTML file, it's creating an ordinary HTML file. However, what about extending that? Let's have a look. I should add a remark. Documentation can exist in two different ways. It can exist as close to the code as possible, which in a class script obviously means you put the information into the class script itself, or it can reside elsewhere. Now, in the past, documentation was almost always created elsewhere for a very simple reason. Memory was short and expensive. That is not true any longer. There is no good reason to keep the documentation elsewhere. Still, very often documentation is kept elsewhere, and the problem with that, according to my experience, is that when people are under pressure, under time pressure, they tend to focus on the code, and they forget about the documentation, and they get out of step. And a couple of years later, the documentation is useless. It's worse, actually, than having no documentation at all, because when the documentation is telling you something which is wrong, that is worse than telling you nothing. If you have no information, you have to look into the code to find out yourself. And that's the reason why I believe is we should change our attitude, and we should put all the code, the documentation, as close to the code as possible. There is a second problem with documentation, but I haven't found a solution for that so far. Nobody is going to debug documentation. Okay, nothing we can do about right now. This function is using ADOC in order to create a help file. So this is a new version of ADOC which not only creates an HTML file, it creates an ordinary HTML file, it creates compiled HTML file. And as you can imagine, you have to set a couple of properties we've already seen in an earlier example, like order doc name path and all that kind of stuff, because that's what HelpAndManual needs in order to do something. And, not surprisingly, ADoc needs to know where the HelpAndManual classes reside. HelpAndManual is an ordinary namespace, but it contains all the classes which make it possible to create the XML file from APL. And as soon as we've done that, we can call the HelpAndManual method of ADoc, and it's doing exactly the same thing we saw a couple of minutes ago, but now on something which is called stripped ADoc. Now, stripped ADoc is ADoc itself, but without any comments inside, for good reasons we will see in a second. We compile that. And we show the help file. By the way, there is a deliberate crash, and the reason for that is when you display an HTML file with the class, what it is called, display help file, it will disappear as soon as a reference pointing to the instance is destroyed. That is a little bit strange, but there's nothing we can do about it. It is a feature of the call I'm doing to the outside world. So it has to be a global, or the function needs to stop. That's what we got from ADoc. It has created all the information about fields, properties, methods, whatsoever. Now, although we have now a full documentation of the public interface of the class, while the internal implementation is completely hidden, we don't have any comments. So we only know what the syntax of the getPrint CSS class is, but we have no idea what the function is doing without the comments. In order to make good use of such comments, we have to have a couple of rules in place. Otherwise, we can't recognize the information we would like to go into the help file. And we are going to look into this in a second. That is the ADoc class, which is, because it's self-contained, is quite a big one. How to enable line numbers. On the notebook, I'm not able to do this by keyboard. So this class has more than 3,000 lines. I'm very grateful that syntax coloring now is much faster than it was in version 12. When we look at a public method, we see that these comments are what I call public comments. In other words, all comments following the header may be interrupted by a blank line. Blank lines are ignored. It may be interrupted by access public instance or a similar keyword. They might turn up in between the comments, are considered to be public comments, and they are extracted automatically from the class script and inserted in our help file. So when we look at our help file, we should see this text turning up under create top of body. I destroyed the help file. Okay, you have to believe me that, but we will see a second example in a second. That is exactly what is going to happen. But ADoc is offering much more information than what we've seen so far. It has also public comments in itself. All the comments starting right after the class definition are self-documenting what ADoc is going to do for you. Until here, finally, the API code starts. That's what I would like to see in the compiled HTML file as well. Now, we need a couple of rules for that, naturally, in order to avoid a complex markup. First simple rule is a line which starts with an asterisk is considered to be a list item. So it's very easy to get a couple of list items, unordered list items. If it starts with a hash or a pound symbol, it's considered to be an ordered list item. Text which is surrounded by these little bit strange, I don't even know what the name is considered to be inline APL code. And if it's a block of APL code, it needs to be between pre-tags. That has nothing to do with APL, with HTML, although I'm using the same tags because it's analyzed by ADOC, so it has nothing to do with HTML in this respect. And finally, every single line is considered to be a paragraph in its own rights. Now, sometimes you might want to connect several of those into a single paragraph. Then a line needs to end with a blank followed by an underscore, then it will be connected automatically with the next line. Of course, we have a strong need for headers of different levels, and that's it. There are no more rules which are considered by the parser as important. Now, let's create a second help file which is not ignoring the first example, ignored that these leading comments. The next one is taking the whole thing and creating a fully fledged file for that. In the first file, we only saw one top container. It was a reference. And reference contained constructors, methods, fields, properties, and destructors. Now we have a second top-level container that is made up by the leading commands. And you see all the information from ADOC, probably formatted. So you can see that this text indeed turns up here, and that this header is displayed here. So we have achieved our goal, right? And it works quite well. Well, there's a problem. That is a single class. That is easy. That is very easy indeed. Now imagine a situation where you have a fully fledged application which comes with lots of classes. That is very different because the classes are not at the same level, so to speak. You have classes which are really important, you need to know about. And there are classes that might be used by other classes, but you never will use them in their own rights, or classes which you very, very rarely use. So probably you would like to have a kind of hierarchy which tells you which classes are more important than others or where to start with. That is a completely new set of problems. And how should we tackle those? Well, let's start with the simple thing to create a HTML file, compiled HTML file which at least contains more than one class. And in order to do this, what I'm going to do is I use the classes I'm using to create such a file itself. That's what I'm interested in. This is the ordinary namespace HelpAndManual, and these are all the classes which consist where the project consists of, plus a couple of other classes which reside inside the sub-namespace enums, or the enumerations you can use. So it's quite a big thing. It's not small. There are a couple of classes involved. The sequence of classes is by default naturally defined by their names. There is no other way. I don't know what to do else. So what we get when we do this looks like this. Now the top container is classes, and for every single class we get a subcontainer, and every single subcontainer then comes with the reference we've already seen about constructor, destructor, methods, fields, properties, and so on. Now that is all fine and nice, but it doesn't tell us anything about important classes, less important classes, or classes we can safely ignore altogether. So obviously we need an additional piece of information which allows us to improve that. In order to achieve that, we have to define the sequence of classes explicitly ourselves. And that's the way it looks like. We create a list and we assign the class names we are interested in a sequence which makes much more sense. For example, we've seen that when we create a compiled HTML project, the first thing we have to do is to create a new instance of the XML.project class. So obviously this is the most important thing, because without that we can't even start. And not surprisingly, styles are the next thing to do, because without styles we can't start. We can't add topics to our help file, and so on. While these classes are used internally, you might never use them, so they are at the very bottom of the thing. Now, because I'm always wondering where the time is going when I'm giving a talk. It's unbelievable. I just started, right, and I have 15 minutes left. So I'm not going through this example. I'm going to the next step, because this is still not what we really need. We need a piece of information which is giving us a kind of big picture, what to do in order to use all these classes. So what's missing is the big picture, introducing the general idea, but also the workflow. What I'm supposed to do. I start with this, and then I do that, and then I do that, and then I compile the stuff. Without knowing this, the whole thing is worthless. I don't know what to do. Now this list looks slightly different. These are still references pointing to classes, and this is true as well, but you can see that there are other things in between, and they are not references. This is ordinary text. And the reason is that these are functions. Okay? So these functions contain pieces of information which gives us the workflow, the big picture, whatever. And again, the rules are the same we saw earlier on in the ADOC class. This adds exactly the piece of information we are looking for, but it is doing more than that when we look at the final help file. It has now two top containers, the big picture and the classes. Now the big picture is the contents of the first function we saw. That is not a surprise. But what we see underneath classes looks very different. It's not any longer simply a list of classes. It's a list of functions, meaning that those functions I've specified also tell the software, when passing through the classes, that they should be considered as containers. So every references following workflow are children of that container. So these are telling you, these pieces of information are telling you how to make use of the classes. What to do first, what to do next. While the function topic helpers tell you about stuff you might be interested to use in order to achieve the goal, but they are not essential to get the whole thing up and running. In the very end, we always see the reference folder. And the reference folder, again, is telling us which fields, properties, methods, and so on is contained. So now it's a fully fledged HTML file which contains everything we need in order to make other people able to make use of such a project. The only thing I've not included into this one is there is no index tab. And the simple reason for that is that I didn't bother so far to create keywords in the topics which go into the compiled HTML file. It's easy to do this, but it's less easy, in fact it's quite time consuming to find really important and something you can make good use of. So the decision which words should go into the index, that is what is a time consuming task, and I haven't bothered so far to do this. The last two examples are dealing with interfaces and with embedded classes. You know, a class can contain itself a class, which is then local to the outside world. Normally you're not interested in embedded classes except when you are dealing with such a class. You're supposed to use it. In that case you might want to have a proper documentation in order to change the parent class. I'm not going into this. It's available, it works, but it's, I think, too complex to look into this right now. What I would like to show at the end of the whole thing is where can you find all this stuff? Why is that?
Internet access.
That is an unpleasant surprise. Anybody an idea?
Still no network.
I was one of those guys who managed to get internet access in this building without any effort. It worked from the start, no problem at all. There were several people who have a couple of grey hairs, but obviously that came to an end.
We can all see it on our own laptops.
So I have to tell, brilliant. When you go to the APL wiki, there is on the main page a link saying open source project or something. And then there are sub-pages because it's offering one for each dialect, and there is a particular one which is called APL. And underneath that one you find a couple of classes doing log files, ADOC itself, and also the classes I've just shown you. So they are open source, you can use them, they are well documented. The only thing you have to make sure, of course you have to have HelpAndManual and the help workshop on your machine in order to get it to work. But that's it. Okay, any questions?
It's all very clear.
I'm surprised. Okay.
Like, did you foresee something for special documentation, for example, for results or for arguments to methods or to functions?
I don't understand the question.
You set up some rules how I can, within my own programs, mark things as to document in a special manner. Did you foresee something like this function takes this kind of arguments, or this method takes this kinds of arguments, needs?
Well, you have to put it into the comments in order to make it available.
As ordinary text.
It is automatically, of course, telling you the header line. So you will, if the header line is providing appropriate information, for example, the names are telling the full story already, there is no need to add additional information because that header line is automatically displayed. And you can see this, by the way. For example, here.
The question is, if you come to a workspace, to some legacy workspace from some person, you will never know, never be able to ask something, and you find some documentation in there that's almost okay. Maybe someplace in the header part there might be something written about the arguments.
Well, it will turn up as long as it is a so-called leading comment. So it will turn up underneath the header. This part. It might not follow the rules, so the formatting might be wrong, but the text will turn up. Every single line might be a single paragraph, which is probably not what you would like to see, but it will work, yes. But there are no legacy applications in this sense, simply because it needs classes. And so far, there are certainly no legacy applications consisting of classes. You can't use the whole stuff on ordinary functions and ordinary namespaces. Of course, it would be possible to do this, but I haven't bothered to even try to achieve.
Just for classes?
Yes.
Okay.
Yes. So if there is any need to do this on ordinary functions, you have to write a little bit of API code to do this on your own. It should be quite easy. Okay, thank you very much. Have a nice day.